Good day, class. Welcome to today's mathematics lesson. My name is Rose Mtimunye, and this lesson is proudly brought to you by the Gauteng Department of Education. So today we are going to be continuing with our 3D objects. We are going to be doing the surface area, the volume, and capacity of triangular prisms. We've already covered some cubes and rectangular prisms as well, right? Okay, so make sure you've got a calculator in front of you. You are definitely going to need it for today's lesson. And as an extra secret weapon, you can save our WhatsApp line 079 454 9535. You can ask us questions and also give us comments about today's lesson. Okay, make sure you ask as soon as that question pops into your mind so I can answer it before the lesson ends. All right. Now, the lesson objectives: by the end of this lesson, you should be able to use appropriate formulae and conversions between units to solve problems, and you should be able to calculate the surface area, the volume, and capacity of triangular prisms. Your pre-knowledge will include your surface area, volume, capacity, and also your properties of 3D objects, and you should also be able to identify the different types of 3D objects. Now we start off our baseline assessment. Remember, we are getting ready for exams and we are actually in the exam season. So everything is a test, right? Right. So we are starting with our baseline assessment. I am going to give you 3 minutes to answer A. Okay. And then when you are done, we'll do the corrections and I'll give you time to do B. You have 3 minutes. Welcome back, class. Let's see how you did with this question. So you had to calculate the length of xy. Now, xy is on the base of wxy, the triangle, right? Okay, so the first thing you would do when you're given a diagram of this form is to check how many triangles you are given, or how many triangles you could work with possibly. And in this case, you can actually work with at least 3 triangles, right? Now, the question says, refer to the diagram below where WZ is equal to 9 centimeters, WY is equal to 23 centimeters, ZX is equal to 6 centimeters. You have to calculate the length of XY. So the first thing we're going to do is use the right angle triangle WZY or WYZ, right, to find the side ZY. It's a right angle triangle. As soon as I say that, you should be thinking about the theorem of Pythagoras. Yes. So you first find the missing side. So that would mean you are going to use the theorem of Pythagoras, the opposite side plus the adjacent side. Those two will be squared, will give you the square of the hypotenuse, right? So you say hypotenuse squared minus the WZ will give you ZY squared, and when you take the square root on both sides, you get zy to be equal to the square root of 448. You can leave it as a surd, okay? That's also acceptable because it's not your final answer. So zy is actually equal to 21,17 centimeters. Now that you have zy, you can use it to subtract zx. Zx is in the triangle WZX, so it's the 6 centimeters. So you can subtract 6 centimeters there, and then you'll be able to get the value of xy. So xy is equal to 15,17, right? Xy is equal to 15,17. Now, this question was out of 4 marks. You're going to get a mark for actually having a statement and a reason for your theorem of Pythagoras, right? And then your manipulation of the formula to get zy as the subject of the formula, the actual value of zy, and the value of xy. All right. So I'll just give you 1 minute to do your corrections for this part. We do have an alternative solution. Please don't think it's only one way. We do have an alternative solution. So just have 1 minute to do these ones quickly. All right, class, let's move on to the alternative solution. Okay. All right. Pardon the alternative solution is actually for the area. I'm so sorry about that. All right, so we are going to move on to the next question. It's to calculate the area of triangle WXY. All right. Now, when we calculate the area of triangle WXY, please make sure you try both methods that you can think of to use, all right, and see if you get the same answer for both. All right. Now, for the first question that we covered, the reason I was thinking about an alternative solution is because you could have actually immediately tried to calculate the area and then found the side. But that is more of a grade 10 method. So let's just try it out on this part. All right, so we're going to do the area of a triangle WXY. I'm going to give you 2 minutes. This question is out of 2 marks. Welcome back, class. So let's see how you did with this one. Remember, I said this question is out of 2 marks. All right. So I have just placed the 21,17 that we calculated earlier for ZY. Okay. Now what we are going to do is to calculate the area of the big triangle and minus the area of the big triangle being WZY or WYZ. And then we'll subtract the area of a WXZ or XWZ, right? And then what is left is going to give us the area of WXY. So that is one of the methods we are going to use there. All right. So we substitute 21,17 as the base and then multiplied by the height, which is WZ at 9 centimeters. That gives us 95,27 centimeters squared once we have substituted it into the half base times height formula. Okay. Now, the next triangle we are going to use is WXZ. So with that one, the base is 6 centimeters and the height is 9 centimeters. So we are going to have a half times 6 times 9, and that will give you 27 centimeters squared. Remember, now you're not writing just centimeters, you're writing centimeters squared. It is area. All right, now you have those two. All right, to get the actual area we are looking for, which is a WXY, we are going to subtract these two areas that we've just calculated here, WZY and WZX. So that means the area of a WXY is going to be 68,27 centimeters squared. Okay. So here what you need is simply the value. You can practice it on your own if you did not use this method, okay? So just get the value that the area is 68,27 centimeters squared. All right? Okay. I hope you have copied it. I want to show you the next method you could have used for this one as well. So the alternative method, you would have used XY, which is 15,17 centimeters, right, as your base, and then used the height WZ, which is 9 centimeters. Remember when I gave you the formulas for area, I was specific about the area of a triangle, that you should train your eye to always recognize the perpendicular height in a triangle and also the base of a triangle, right? So we are using those two, so it will be half the area of WXY will be equal to half the base times the height, the base here, and your height will be XY and WZ. So you substitute those and you should notice that you get the same value, which is 68,27 centimeters. So I'll just give you 1 minute to quickly amend your work if you need to, or correct it when necessary. Okay, before we do that, let's just write down our marks. Okay. All right, so it's 2 marks. You get 1 mark for substituting correctly into the formula and a final mark for the actual value of the area. Okay. You have 1 minute. Okay, class. let us move on. So I hope you have an idea of whether you need to work on your area and perimeter skills, and especially area that we've covered today. Remember, now we are revising. This is a question that would be an exam type of question. So if you got all of these correct, well done. You would have gotten a full 6 marks, already looking good. Okay. Now, if you struggled with these questions, do practice. Go and find more past papers and answer the questions. Even if it's similar questions, just keep practicing and finding the necessary strategies that will assist you in being able to answer them. Okay, so let's get into today's concepts. We're starting off with 3D objects. These are geometrical objects that have 3 dimensions, namely length, width, breadth, and height. All right, I will show you pictures. I will have the physical objects in a moment. I will show them to you. Okay, all right. And then a prism. So a prism is an object that when cut has the same cross section all throughout. Okay, so basically when you think about cheese in a triangular form, right? If you slice it along one of the rectangular sides, the cheese will still remain a triangular form. So that would mean that it becomes a prism in that shape, right? So when you look here, when we cut this shape, you see it's still a triangular prism. Okay. Then volume gives the amount of space an object will take up, and surface area is the total area of the flat faces and curved surfaces of a solid. So when we look at surface area, we are looking at all the exposed faces of the shape. Okay, now we are going to discuss the net of a triangular prism. All right, it's very important to note that the net of a triangular prism, the measurements of the actual rectangles is dependent on the types of triangles that make up the triangular prism. Okay, makes sense? So your bases will decide the type of rectangle you're going to have. For example, here this triangular prism will have 5 faces. That is the general standard for a triangular prism, right? But it will have 3 rectangles that are the same, so they'll have the same measurements. Okay, so all of them will have 10 times 4 is their area. And then you will have 2 congruent triangles as well. All right, so when we draw the net, we are going to have the front, okay, 10 centimeters, and then 4 centimeters there. The back will have the same measurements as well, and also the bottom will have the same measurements in this case. Then you have your front triangle that is measured at 4 centimeters by 4 centimeters, and also your back triangle will have the same. All right, don't worry, we still have another net. You can just use this one. Okay, so I want us to quickly think about triangular prisms in the scenario of life. What types of items do you recognize as triangular prisms? Okay, have you thought about a triangular camping tent maybe? Okay, a slice of cake could qualify, right? Things like that. So I know most of you have seen that chocolate we use as well, the one that looks like little triangles, right? Yes, you know it. Okay, I won't say the name, just now you want to have some. Okay, so there's quite a few items you can think of that would almost give us the shape of a triangular prism, right? So now that you can see it or visualize it, imagine this was your tent and then the dotted line was the zip we use as our entrance for into the tent. Okay, makes sense. Okay, now it has life. Let's imagine we open up this triangular prism. We are going to have 3 rectangles and 2 triangles. Remember, we've just done the net, right? Okay, now with the net looking like this, how would we calculate the area of each of the components? All right, so in this case, the first rectangle will be given by a times the height. We are talking about the height between the 2 bases, right? So the capital H represents the distance between the 2 triangles. Okay, Remember, I usually say when you think about a triangular prism, imagine a flat triangle that was basically stretched up, and then the sides now are rectangles. Okay. Right, and then we have B times H as well for the middle rectangle, and then the last one will be C times H. Then to get the area of the triangles, they are the same in this case, so it will be half base times height for each of them. All right, so why do we need to know the areas? Because when we get surface area, when we calculate surface area, we are actually adding all the areas that make up the object, right? So surface area will be the area of the two triangles plus the area of the first rectangle plus the second one plus the third one, A, B, and C. Okay, so we would add those areas. So the formula, you can use it in this standard form where you can see all the components, okay, and you would substitute in each one of them, or you can factorize the formula or simplify it. Now 2 times a half gives you 1. That means in the first bracket you just have B and H left. Then you'd add that 2, you take out a common factor here, H, so that's a common factor. You would divide all the brackets by H and you'd be left with H outside the bracket times A plus B plus C. Where do you get A plus B plus C? Those are the dimensions of your triangle. So that means you would say the base of the triangle times the height of the triangle, right? Plus the distance between the two triangles, okay? Plus the distance between the two triangles multiplied by the sum of the sides of the triangles. Make sense? Okay. All right, so please write down both formulas. We are going to use them. Don't forget to send us your WhatsApp questions on 079-454-9535. Please make sure you ask your questions during this live session, okay, so that you get the assistance before the lesson ends. All right. Okay, so now let's look at volume, right? You remember from our previous lesson, we said that in general, volume is equal to the base area times the height, and now we know that the height is the distance between the two bases. Okay, so a triangular prism is made up of triangular bases. Okay, you can even identify the same triangles on your net. Do you see them? Okay, so that means that you are going to have the area of the base, which is a triangle, half base times height, multiplied by the distance between the two bases. Very important, pardon? It's very important that you note the difference between the H's we use. You see, one of the height of the triangle, we are going to use a small letter, and then the height, which is considered to be the distance between the two bases, is going to be a capital letter. Okay, so you have half base times height multiplied by the distance between the two bases, okay, as your formula there. Sorry. All right, I just want you to be able to copy this one as well. All right, do you have this? Do send those pictures. Don't forget, we are here to help you if you have questions. Okay, now that you've got this, we can move on. So we start off with this example, which I am going to ask you to do some work as well while we do it. It says calculate the surface area and volume of the given figure. So here, to calculate surface area, we need to add all the faces, right? And it is a triangular prism, as you can see. So we have two triangles there that have the same measurements, right? Hence I have highlighted them. So we are going to use this formula without having simplified it, because I want you to be able to see that you can use the formula in both forms, right? You can either use it where it's been simplified, or you can use it in its entirety like this. Okay, so if you are not sure about how to compact it or make it factorized, just use it as it is, because then you can keep track of all the faces that you are looking at, because you can see that this is my back triangle front, this is my back triangle and front triangle, this is your uh, bottom rectangle, your top rectangle, and one of the sides. Okay, right, so here we are going to substitute all our measurements. The triangle is a right angle triangle, so the height is 2 meters and the base is 1,5 meters. So we substitute those there into the formula, and then our A, B, and C in this case are given as 2 meters for A. This is your A, and then your B is given as 1.5 meters and your C is 2,5 centimeters. Right? You recognize all of those? Right. And then the 10 meters, what does it represent? It represents your capital H, which is the distance between the two bases. All right. Right. So you've got all of these, and then you know that your A is also going to be your H in this case. Okay. So once you've substituted that, you are going to just simplify each of your brackets. 2 times 10 gives you 20. 1.5 times 10 will give you 15. And 2.5 times 10 will move the comma to one place on the right, so you get 25. And you have a half times 2 there. That gives you 3. So from here, you just add all of these and you get 63 meters squared. Okay? All right. So I would like for you to try calculating the volume of the shape. All right, so I'll just give you the formula first and also the components for you to use. So we are working with a triangle that has all the, that is the base, right? Remember, you need to calculate your base area times the height, and the height here is 10 meters. There it is, it's the distance between the two triangles. So you've got those. Now, this is the formula you're going to use. Please take 2 minutes and actually calculate the volume of the shape before we move on. Okay, did you manage to calculate the volume? I know you did. Like, I have full confidence in you, right? Okay, so what we want to do here is to substitute into the formula half base times height of the triangle multiplied by the distance between the two bases. Okay, so you are going to have half times 1.5 times 2, that multiplied by 10, and you get it to be equal to 15 meters cubed. Well done if you got 15 meters cubed. Good job. Okay. Right. I was just giving you enough time for you to make sure you've got this one. Do you? If you don't, please do keep practicing. I am going to give you another similar question in a moment in the activity. All right. There's our activity. It says calculate the surface area, the volume and capacity of the figure below. And you also have to calculate the new volume of the triangular prism if both dimensions of a triangle are doubled. Okay, so here what I'm going to ask you to do is to first calculate just the surface area. All right, I'll give you 3 minutes to do that. So you have 3 minutes to calculate the surface area. Welcome back, class. So I have managed to locate some 3D objects. Okay, so this is what you'd consider a cylinder, right? Now, when we were talking about how you would be able to cut the shape and would retain its the same net as well, because if we were to cut off a part of the shape like this, maybe remove this half, this little piece, it would still be a cylinder, and that's what makes it a prism, right? We also have a cube. Okay, if you were to slice part of this cube off, you would still be left with a cube, and that is what makes it a prism. Okay, you have seen these as well because we did a lesson on a rectangular prism, right? We did a lesson on a rectangular prism in the previous lesson, as well as a cube. I do not have a triangular prism in my bag right now, but when I find it, if I find it before the end of this lesson, I will definitely show it to you, and hopefully we can just unpack it and open it up and see what we are talking about when we are talking about cutting it, and it will still look the same and it will still remain a triangular prism. Okay, all right, so let's look at our corrections for calculating the surface area. I'll just put these to the side there. All right. Right. So the surface area, what would you write down? You'd have to first check the dimensions of each of the rectangles. Very important. Before you even do your calculations, you must know what the dimensions of each face is going to be, the measurements, right? So in this case, you're going to have two triangles that are the same. So there'll be 4 centimeters by 3 centimeters, okay? And then you are going to have one rectangle that is 3 centimeters by 10 centimeters. So it uses the height of the triangle and also the distance between the two triangles. Then your bottom rectangle is going to be 4 centimeters by 10 centimeters. So that one uses the base of the triangle and the distance between the two triangles. And then obviously your top rectangle is 5 centimeters by 10 centimeters. You notice they do have something in common, the 10 centimeters every time. Hence, we usually just write the H outside the bracket and then add A, which is 3 centimeters, B, which is 4 centimeters, and C, which is 5 centimeters. Okay, so we are going to use the shortened version. If you've used the full formula, that's also acceptable. Please do not stress. Just send me your pictures. I'd like to see how you did on this question on 079 454 9535. Okay, so here we multiply 4 times 3 and then add 10 times 3 plus 4 plus 5. Now the rules now are BODMAS rules at this stage. So what we need to do is to first make sure we deal with the brackets. So 3 plus 4 plus 5 will give you 12, and 4 times 3 also gives you 12. Okay, so you're adding 12 plus 10 times 12, and that gives you 12 plus 120. Therefore, your surface area should be 132 centimeters. Do you have that? Well done if you do. If you were asked to do such a question, it would at least be 5 to 7 marks, depending on whether you've been given a formula or you have just been asked to do the calculations without a formula. Okay, so I'll give you some time to do the corrections, plus you must continue to calculate the volume and also the capacity. Okay, we can start off with the volume for now. You can just do the volume. So I'll give you 4 minutes. 1 minute will be for your corrections, and then immediately when you're done, you'll continue and calculate the volume using the 3 minutes. So you have 4 minutes. Okay, class, how did the second part go? Do send me those pictures on 079 454 9535. Okay. All right. So I had asked you to calculate the volume. So volume, remember, is given by the area of the base multiplied by the height, which is the distance between the two triangles in this case, right? So the base is a triangle. So we are going to use 3 centimeters by 4 centimeters, and we'll say a half times 3 times 4, and then multiply that by 10. Okay. So if you've substituted correctly, you get a mark. Do you have all of those? All right. And then you are going to have 6 times 10, and that gives you 60 centimeters cubed. Now this is your volume. All right. Ideally, this question would be out of 2 marks. Okay. Then next, you are calculating capacity. Now, capacity is a little tricky, isn't it? But if you remember what we learned last week in our previous lesson, you definitely are going to be able to do this. Or let me just give you a hint. Think about milliliters versus centimeters cubed. You still remember that? Okay, in case you have to go back into your mental archives and look it up first, I'll give you 2 minutes, okay? You just have 2 minutes to do the capacity. Okay, do you guys have the capacity? All right, let's see if you still remember that 1 centimeter cubed will give you 1 milliliter. All right, so that simply means that you needed to use your volume, which is 60 centimeters cubed, and convert that to milliliters. So you should have 60 milliliters. Do you have that? If you do, well done. So for the purposes of this question, it's out of 6. Well done if you got all 6 questions correct. So here, I know you've got this, right? You've used your 2 minutes and you did your corrections and you went on to find the capacity. I trust you. You are very efficient, right? Okay, so I'm waiting to see those pictures for this first question on 079 454 9535. Please send me those WhatsApp questions. Today is our last lesson, so I would like to actually have the opportunity to say goodbye to you guys, okay? So do be in touch. All right. So we look at the second question. It says calculate the new volume of the triangular prism if both dimensions of a triangle are doubled. Right, so here, first thing you need to do is to double the dimensions that you need to double first, right? You have to double the dimensions of the triangle, right? And then after you've done that, calculate the volume. Okay, so I'll just give you 3 minutes to start this question, and let's see how far you are able to get in order to calculate the volume. Welcome back, class. So let's see what you had to do. The first thing you had to do was double the dimensions of the triangles. So you could have done this on your diagram, okay? So you know that your new dimensions will be 3 times 2, which is now 6 centimeters there. You also have 4 times 2, which is now 8 centimeters, right? I can just double the other dimension even though we are not going to use it. These would be the new dimensions of the triangle. So you're basically working with a slightly bigger triangular prism, right? Makes sense. So if you're working with a bigger triangular prism, it would make sense that also the volume would be a little bit bigger, right? So the volume of the new volume will be equal to a half base times height multiplied by the distance between the two triangles. Okay, so here I'm showing you how you could have incorporated the doubling, right? So you would substitute your 8 and your 6 there. So you have half times 8 times 6 multiplied by 10 there. And that gives you 24 times 10, and it's equal to 240 centimeters cubed, right? Okay, So this is what you should have gotten for this question. I hope you got this correct. Right. Now let's talk about what this actually means. Right. You remember we earlier had 60 centimeters cubed for the volume of this triangular prism. Right. This triangular prism was 60 centimeters cubed. Okay. So when we think about it, 60 times 4 would give us 240 centimeters cubed, right? So this is the same as having 60 times 2 squared. You see that? When you think about this 2, where have you seen this 2 before? It's here. There's the 2. So when you double both dimensions of the triangle, okay? When you double both dimensions in the triangle, the volume will be increased by k squared. Do you see that? Okay. What I'm going to challenge you with is for you to do your own investigation, all right? And see how is the volume affected when you just double one dimension of the triangle. What I mean by that is instead of having a half times 2b times 2h, you just have a half times 2b times h, like this, and then multiplied by capital H. How would the volume that you get here differ from the volume that you get there? And that is my challenge to you, okay? Please do have fun in doing that investigation. So what we want to discover is the effect if none of the dimensions are doubled, if one dimension is doubled, and if two dimensions are doubled. Okay. All right, so that's just a good way to think about the volume. So now I am going to show you your homework. Unfortunately, I haven't received any questions yet. If you do have a question, you have 1 minute to send it through on 079-454-9535, okay? And then I'll just give you a quick minute for you to screenshot, take a picture of this homework. It is also an exam type of question, so do practice and also make sure you show your steps. Notice how the questions are worth 8 marks each, so use the timing, 1 minute per mark, so that you don't go over that 15-minute marker. Okay, so I'll just give you 1 minute to get your homework. Okay, class, so I don't have any questions from you. I take it you were very, very busy doing your work, right? And I trust that you understood everything that we worked on today. So do practice. Like I said, look for your papers. We are going to move on to our summary. So the formulas that you need to keep in mind are the formula for surface area, and also don't forget that your surface area or the formulas that you are going to use are going to be dependent on the dimensions that are given in your triangular prism, right? And also very important that your rectangles depend on the dimensions of the triangle. So if you have an isosceles triangle, the dimensions of that rectangle would be different from an equilateral triangle or from a right angle triangle. So be very, very mindful of that, because it will give you an idea whether you have three congruent rectangles, two congruent rectangles, or none of the rectangles have the same dimensions. Okay, right? And then the formula for volume, in general, what we say is the volume of a prism is going to be given by the area of the base multiplied by the height, right? So you always use half base times height for a triangle, then multiplied by the distance between the two triangles. Okay, and very, very important, notice the differences between the H's. Okay, the H's have different, one is capital, one is small letter, so that you're able to have to differentiate between them. So also when you write them, do make sure you write them in that way. Right. So let me say good luck to you for your exams. I hope and I know you will do very, very well in your final exams, right? Keep studying, keep practicing. Remember, mathematics requires that you practice every day. The more you practice, the better you will be. So please work hard on it. Today is our last lesson for the year. I am wishing you all the best. Until next time.